Everyone got it wrong except one person. The mathematician has it wrong because he's begging the question. William Lane Craig is wrong because he makes a false analogy. They're all making false assumptions. But the Kalam scholars got it right. That's what I'm going to show you in this video.
The Kalam Cosmological Argument proves that the universe began to exist. It's a proof by contradiction. It says that if the universe didn't begin to exist, then that means it's existed for an infinite quantity of time. But if you think carefully about an infinite quantity of time, you can see that it's impossible because it leads to a contradiction. This is an old argument. Modern philosophers have only discovered it very recently. And since they've discovered it, it sparked a debate and a question over whether the idea of mathematical infinities have undermined the traditional Kalam argument. Bill Craig argues that they don't, but he's not a mutakallim. And so he brings his own philosophical and religious commitments. He's made some important contributions. I'm also going to show you why it hasn't undermined the Kalam argument. But I'm going to show you the way that someone like Imam Al-Ghazali or Sa'aduddin al-Taftazani, the author of Sharh al-Aqaid al-Nasafiyya, would have done. This is God's cosmos. The reason why mathematical infinities don't undermine the Kalam argument is because they don't apply to quantities of time. It's what philosophers call a category mistake. Noam Chomsky illustrated the idea with the statement, "Green ideas sleep furiously."
Wait, what does that mean?
It doesn't have a meaning because these concepts don't apply to each other. And in the same way, mathematical infinities don't apply to quantities of time.
Why not?
When you think of mathematics and infinity, the most common idea that comes to people's mind is the infinity symbol that's a sideways number 8. They call it a lazy 8 because it looks like it's sleeping. The lazy 8 is not a number. It doesn't describe a quantity of time. In calculus, there's a concept called limits. And we learn that functions like 1 over x have limits. So they'll say that the limit of 1 over x as x approaches infinity is 0. What this means is that as x gets larger and larger, 1 over x gets closer and closer to 0. But x never reaches infinity, and 1 over x never reaches 0. At any given point, x is a finite number. There's no number on the number line called infinity. The lazy 8 is not a number. It's a process of getting bigger and bigger.
So the lazy 8 just means that any finite number can, at any moment, be increased to another finite number, just like the did not did to example.
Exactly, just like that. Philosophers call this a potential infinity. This idea of potential infinity, it's in this sense that we say that the pleasures of paradise or the horrors of hell are infinite. They're potentially infinite. When the Quran says that the inhabitants of paradise will remain in it forever, خالدين فيها, or that the inhabitants of hell, the permanent ones among them, will remain in it forever, Allah protect us from the hellfire, خالدين فيها, then what it's saying is that there will be no moment in paradise, nor any moment in the hellfire that will not be followed by another moment. It's a process of increase that keeps on going on and on and on. But if you look at any particular moment in time and you count the moments from that moment all the way back to the time when God created paradise and hell, it's going to be a finite number. So a potential infinity is a process. and it doesn't conflict with the Kalam argument. The Kalam argument isn't about disproving potential infinities, it's about disproving an actual infinity.
That's straightforward. Mathematical infinities don't undermine the Kalam argument at all. Why so much confusion then?
So it's not this lazy 8 that's confusing. There's another kind of infinity in mathematics. It's not as well known. It's represented by the Hebrew letter Aleph, which looks like a fancy X. It's written with a subscript. If there's a 0, it's called Aleph-naught. If there's a 1, it's called Aleph-1, and so on. Mathematicians call these transfinite numbers, and they're supposed to represent the different kinds of sizes of infinite sets.
So does that mean that there are many different sizes of infinity?
Different sizes of infinity, they have a meaning within the context of set theory. But when we take that meaning and we apply it to quantities of time in the context of the Kalam Cosmological Argument, it becomes meaningless. But it's not easy to see because many people don't understand exactly what these transfinite numbers mean. They belong to an area of study called the Foundations of Mathematics. I'm going to try and explain to you as simply as I can what they're all about. Not so that you become an expert in the Foundations of Mathematics, but I want you to see why it's a category mistake. So the first thing that you need to understand is this idea of a mathematical set. A mathematical set is a collection of mathematical objects. An example of a mathematical object is a number. So the collection of numbers from 1 to 20, consider all of these numbers together, the collection, this is a set. It's a finite set because it has a beginning, it begins at 1, and it has an end at 20. If we take another set, like the set of natural numbers, the natural numbers are 1, 2, 3, 4, 5, keep on going. This set, mathematicians will say, is an infinite set. It doesn't have an end.
That looks like a potential infinity.
Yes, but right now, what mathematicians are saying is consider this set from 1, and it keeps on going, 2, 3, 4, 5, 6, 7, on and on and on, without end. Consider it all at once and give it a size. They call that size Aleph-naught. It's the first transfinite number.
Aleph-naught can't be anywhere on the number line because it's not a number. It's not a measure of quantity.
That's why they don't define Aleph-naught with any number. They define it as a process. The process is called one-to-one correspondence. Here's how it works. Let's take an infinite set, the set of natural numbers. We want to define its size. We can't find a number. So what are we going to do? We're going to define its size with a process. We're going to take a subset. Let's take from 10 onwards. Now we're going to set up a one-to-one correspondence. We're going to take the first element in the parent set, 1, and draw a line from it to the first element in the subset, 10. There's a correspondence. Then we're going to take the second element in each, 2 to 11, and we keep on going. What it means for the set of natural numbers to be infinite is that you can keep on doing this without end. You can keep on going on and on and on. You can take every element in the parent set and put it into unique correspondence between it and some element in the subset. This is called Aleph-naught. This is what it means for it to have a size of Aleph-naught. You can't do that with a finite set. If you take the set of numbers from 1 to 20, and then you take a subset from 10 to 20, and you try to set up a one-to-one correspondence, there'll be 10 elements left over in the parent set that you can't correspond to anything. So it's not an infinite set. You can only set up a one-to-one correspondence with a subset if the set is infinite. That process, that's called Aleph-naught.
So what it means for the set of natural numbers to be infinite is that it can be placed into a never-ending one-to-one correspondence with its subset.
Yes. And That's why it's a category mistake to say that the quantity of time that's elapsed since the beginning of the universe is Aleph-naught. If I ask you about a quantity of time, how long has it been since Muhammad al-Fatih conquered Constantinople? Since 1453. If you give me a number, it's a coherent answer. It makes sense because that number can be used to describe a quantity of time. But if you tell me that the quantity of time is such that you can never count it, because when you try to add it up using the elements, you don't come to any number. And therefore, you're just going to set up a one-to-one correspondence with its subset. You haven't told me anything. You haven't told me how big that quantity of time is.
I see what you're saying, but couldn't a mathematician say that the quantity of time from now into the past doesn't have an endpoint, and that it can be put into a never-ending one-to-one correspondence with its subset?
You have to understand what he's doing when he says that. He's not giving you a number, he's not giving you a size, he's not giving you a quantity. What he's saying is that since that quantity of time is nowhere on the number line, doesn't have a beginning, you can do this operation called one-to-one correspondence. But he hasn't given you a size. Has he proven that the universe didn't begin to exist, that the quantity of time doesn't have a beginning?
No, he hasn't. He's just said that since it hasn't, it can fit into a never-ending correspondence.
Yes, exactly. He's committed a logical fallacy called begging the question. He's assuming what needs to be proven. If the quantity of time doesn't have a beginning, then it can be put into a one-to-one correspondence according to his model. But does it have a beginning or does it not have a beginning? That's the first thing he needs to ascertain. He's just assuming that it doesn't and then saying the operation applies to it. Mathematicians come up with all kinds of models and systems and they present them to scientists. Scientists don't just pick them up and assume that they apply to the real world. They do experiments. They check, can the real world be described with this mathematical model, with this mathematical system? The same thing with the mutakallimun. They're going to say, can it be used? Does it apply? Does it not apply? And they're going to do that by first trying to figure out whether or not an infinite quantity of time makes sense. And they have arguments that show that they don't, that they're impossible. We've gone through a bunch of intuitive arguments and we have the Kalam Cosmological Argument. So an infinite quantity of time is impossible. Therefore, the time into the past cannot be put into a one-to-one correspondence with its subset.
That makes a lot of sense. The only confusion I have is that both the mathematicians and the mutakallimun use the idea of one-to-one correspondence, yet they come to different conclusions.
I was hoping you'd ask that question. You're right. Let's review the Kalam argument. What did the mutakallimun say? They said that if the quantity of time from now into the past is infinite, then you can put the whole quantity into a one-to-one correspondence with its subset. And that entails that the part is equal to the whole and smaller than it at the same time. And that's a contradiction. So they said, therefore, the past quantity of time cannot be infinite. Therefore, the universe began to exist. Therefore, God exists. We're going to look at that in the next episode, inshallah. Then they anticipated objections. They said someone could say that if you take the set of natural numbers, 1, 2, 3, 4, 5, and so on, they said somebody could say that the set of natural numbers can be put into a one-to-one correspondence with its subset without that entailing any contradiction.
That's exactly what the mathematicians are doing.
Yes, that's exactly what mathematicians are doing today. The mutakallimun anticipated that. They gave two answers to this objection. The first answer, they said that the idea of an infinite set is something that I can think about in the mind. I can set up a one-to-one correspondence with this infinite set in my mind, But whether or not I can do that to the quantity of time in the real world depends on whether a quantity of time that's never ending is possible. So I can't just beg the question. First, I have to figure out whether or not that quantity of time is possible. Then I can see if I can apply this one-to-one correspondence to it. And since the argument shows that that infinite quantity of time is impossible, that one-to-one correspondence does not apply. That's the first answer. The second answer is what I find really interesting. Some mutakallimun, they said that the concept of an infinite set does not exist even in the mind. If I say to you, imagine an infinite set, what's in your mind? You're going to think 1, 2, 3, 4, 5, a collection of numbers. And you're going to keep in your mind that, well, there's this thing called addition. I can keep on adding addition. So even though all these infinite numbers aren't there in my mind, I can keep on making more and more numbers. But you never have an actual infinite set in your mind. You never imagine it. And you also, because you don't have an actual infinite set in your mind, there's no actual never-ending one-to-one correspondence. There's no such thing. So these mutakallimun, they would say that there's no such thing as a one-to-one correspondence that never ends, and there's no such thing as an infinite set. This is not the mainstream view in modern mathematics. Most mathematicians will not agree with this, but there are some philosophers that do. And personally, if you ask me, I agree with the philosophers, but the first answer also does the job.
It's really amazing how the mutakallimun expected these objections and answered them hundreds of years ago.
Absolutely. Kalam gives you clarity. It gives you clarity when you're doing math, and it also gives you clarity when you're doing science. Without Kalam, scientists are confused. If you like this episode, then check out my Why Islam is True course, in which I teach you 4 rational arguments that the Prophet Muhammad ﷺ himself used to show that Islam is true. Learning on YouTube is great, but if you want to reach a learning goal, a learning destination, like how to make rational arguments, how to think critically as a Muslim, how to engage with modern science as a Muslim, then you need to follow a map that's been specifically designed to take you to your learning goal, step by step, through a series of carefully designed learning objectives and learning activities that take you to your final learning destination. That's how this course has been designed. This course shows you the what, the why, and the how. It shows you what we believe as Muslims. It shows you why those beliefs are based on evidence and 100% true based on Quranic rational arguments. And it shows you how to use those arguments to address common objections against Islam by atheists and others on topics such as evolution, the problem of evil, the age of Aisha, and much more. It consists of 20 modules, and it includes bi-weekly live sessions with me, pre-recorded lessons with 81 bite-sized videos, 247 application activities and real-world scenarios, a 24/7 community where you can ask a question and get it answered within 24 hours, and there's an option to buy a course textbook as well. Find out more at www.whyislamis.true/course and learn why Islamic seminaries are adopting this course as part of their curriculum to train the next generations of scholars. This course is actually the first and prerequisite course in the Basira classical curriculum in modern context, a 4-year curriculum consisting of 31 courses that will teach you everything that a Muslim needs to know about their deen and be ready for modern society. This 4-year Basira seminary curriculum is based entirely on the Muslim scholarly tradition, but it teaches you how to apply that tradition to the world in which we live, and it's taught completely in English. Why Islam is True is the first course in that 31 course curriculum. Check it out at www.whyislamis.true.
www.whyislamistrue.com/course.